All right, hello. So this is your video notes for this weekend, and it should be very similar to how you were solving in class. So you want to go ahead and title this, again, that's too big. You want to go ahead and title this Unit 4.14, solving quadratics. Solving quadratics by factoring. And specifically with word problems. Okay, so what we have here is an example that's very similar to to the example that was given in class. We're going to go ahead and read the problem first, and then we'll go ahead and actually answer some of the questions. So the same science class in example 2, meaning the same science class from your classwork, adjusted their ball launcher so that it could accommodate a heavier ball. Looks something like this. They moved the launcher to the roof of a 23-story building and launched an 8.8-pound shot put straight up into the air. Note that the Olympic and high school women used the 8.8-pound shot, but put in track and field competitions. The motion is described by the function h of t is equal to negative 16t squared plus 32t plus 240, where h of t represents the height in feet of the shot put above the ground with the respect of time t in seconds. Important, no one was harmed during this experiment. Sketch the function and identify the key features of the graph, such as the y-intercepts, zeros, roots, axis of symmetry, and vertex. All right, so we have a lot going on. There's just a lot of words on the paper. We need to annotate. Okay, so it says they moved the launcher to the roof of a 23-story building and launched an 8.8-pound shot. That's the first math thing I see, but it doesn't really particularly relate to helping me find the key features. The next thing that I see here is h of t is equal to this. So this represents the motion. So this tells me I can already predict that we're going to have a parabola, and this is negative. So I'm making a prediction here that it's going to look something like this, like we've seen in class. Okay, so let's keep going. So right here, it says that h of t represents the height in feet. Okay, so that seems pretty important. And we also know t seconds. So we're comparing height in feet and also time in t seconds. Okay, great. So in your notebooks, we're going to go ahead and actually go ahead and answer this. So we want to sketch the function and identify these key features. All right, so let's go ahead and get started. Here we go. So we have, let's go ahead and write down what we know. We have h of t is equal to negative 16t squared plus 32t plus 240. Okay, so what this means is that we need to somehow find our roots, right? So our zeros are roots. Where does this ball land and at what point? So I'm going to go ahead and set this equal to 0. And go ahead and realize that I need to eventually find my zeros or my roots, the x values. Okay, well, these look too big, and I really don't want to do box method with that. So my first step is also to see, can I take the GCF of this? And the answer is yes. The GCF for this, the 16t squared, 32t, and positive 240 is negative 16. So I'm going to factor out a negative 16. And so that will become t squared minus 2t, and then minus 15. Okay. And you can always check if you do negative 16 times t squared, that does give me negative 16t squared. Negative 16 times negative 2t does give me positive 32t. Negative 16 times negative 15 does give me 240. So that tends to work. Okay, great. So what I need to do is continue on in factoring. So I write negative 16, and I want to get the two factors that multiply to get back this trinomial. So a key thing here, once you factor out a negative, you just have to work inside the parentheses, okay? So right here, this is where you all would do box method on the side, and you put t squared here, and then you put negative 15, and it has to add up to negative 2t, and you'll realize once you do all of that work, you'll get t plus 3, and then t minus 5. When you do all of that work, okay? So here we have t plus 3 and then t minus 5. Whew, okay, now we're done with that. And from there, we continue to solve, and we're going to use zero product property. And you only need to do, hold on, let me see. So once you're here at 0, you want to get these binomials by itself. So what you can do is you can divide this by negative 16 on both sides to get rid of that negative 16. So these will cancel and give you 1, and then 0 divided by negative 16 will still give us 0. So we're left over with t plus 3 times t minus 5, right? And that's a lot easier, and we can do zero product property for each of these, and we'll get t plus 3 equals 0 and t minus 5 equals 0. And we'll have t is equal to negative 3 and t is equal to positive 5. Okay, great. So these represent our zeros or our roots. Okay, now we can go ahead and use this chart or this graph to sketch. So we can start here. I'm going to do my very best to do this on the computer. Ooh, okay. Doing my best. Okay. All right, so we can sketch negative 3. So 1, 2, 3. Here's negative 3. T is equal to negative 3. And then we have positive 5. 1, 2, 3, 4, and 5. So t is equal to positive 5. Great. So we found the roots. Check. We need to find the y-intercepts or the axis of symmetry and vertex. Okay, so we need to do some algebra here to help us figure this out. In order to find our vertex, we need to find out at what point will it be cut in half. So what you're going to do is you're just going to keep going. You're going to start at the roots, and you're going to keep going towards the middle until you meet a point where they both meet. Okay, you keep going, and you keep going, and finally it's right here. So on this particular line here, we'll have that's equal to x equals 1. So this represents our axis of symmetry. All right, so we have our axis of symmetry. Great. So now we can find. Remember, the axis of symmetry is the kind of like the imaginary line that cuts the parabola in half, and we want to go ahead and find the vertex. Actually, at what high point will that be? And the only way for us to do that is to create a lovely t-chart here. So we have t and h of t. So remember, t is our input, and then h of t is our output. And I can go ahead also to label what those are on the graph as well. So here, this represents t, and then this represents the height, h of t. So this is the height, which is our output. And then t, which is in seconds, which also represents our input. Okay, so we basically want to figure out at what point on this 1 value here, what point will it be at the highest. So we're going to substitute in 1. So we take our original equation, or we can use our factor equation. It doesn't really matter, but I'll use the original. So here we have the original, which is h of t is equal to negative 16 t squared. I'm going to leave space because I'm going to be substituting in that 1, plus 32 space plus 240. Okay, so what we're going to do is we're going to substitute in this 1 right here, and then this 1 in here as well. So once you do that, you can type this into the calculator, and what you'll get is a number, and it will be 256. Okay, so what that means is when the time is 1 second, the ball will be at 256 feet. Okay, oh yeah, our height, I forgot to say this, our height is also in feet. Make sure you annotate that. So what that means is we can go ahead and sketch. So we can call this 50, we can call this 100, this can be 150, 200, 250, and then 300. Okay, so about 256, so it's going to be somewhere like right here, is where our highest point is, 256. So we can go ahead and draw our parabola as best as we can here, and we'll bring it back down like so. Okay, and that represents our vertex. Okay, so that's our vertex. And I think we got our axis of symmetry, we got our vertex, y-intercept. We're going to answer this question right now, so we can go ahead and do that. So if we want to find our y-intercept, actually there's a question down here where we'll get to that. I'll save that question, or save that part on our graph in a moment. Okay, so I'll say to you all that right now, this is probably the only question that will take you the longest, is sketching, because you have to find all the parts, you have to use zero-part property, you have to use substitution using the original equation, and so on. It takes a lot of steps. Now, after you do that, then you can answer all these other quick questions. So these will go pretty fast. So it says, after how many seconds does the shot put hit the ground? Okay, so we have two zeros. We have t equals -3 and t equals 5. Well, we can't have -3 seconds, so that one doesn't make sense. So when does the shot put hit the ground? Well, it would be at 5 seconds. So right here, what we can say is at 5 seconds, the shot put will hit the ground, will hit the ground. Okay, that's it. That's all you need to say for this, and we'll move on to the next question. What is the maximum height of the shot put? All right, so maximum height. So that means whenever we're talking about maximum, or if you see minimum, that's a clue to say, oh yeah, I need to look at my vertex. Okay, and so we labeled our vertex already, and we said at 1 second, the highest it will be is at 256 feet. So that's exactly what we have to say. So right here, we can say the maximum height is where t equals 1 second. So the maximum height is at 256 feet. And we're done. Yay. Okay, so moving on to D. See, I told you all, these will go by really, really fast after we've done all that hard work. All right, for D, it says, what is the value of h of 0, and what does it mean for this problem? Okay, so I told you all I would wait for the y-intercept because I want to talk about this notation. So if we see h of 0, well, if we go back to this lovely t-chart, all it's referring to is basically the way you read this is you want to see at what, when t is 0, so when t is 0, let me get a different color here, so this is purple. When t is 0, what does that mean, right? So let's go ahead and actually calculate this. So we actually need to substitute again. So I'm going to use my original equation. So we have h of t is equal to -16 with parentheses squared, and then plus 32 with parentheses plus 240. Okay, so all that really means is what happens when t is 0. So all we have to do is substitute in 0 in here and figure out what that output looks like. So here, since that's what we want to find, we can just write y is equal to this value. Okay, so we want to figure out what that y value is, or our output. I'll go ahead and erase that. You don't have to actually write that. So here, anything times 0 is just going to be 0, and then 32 times 0 is also 0, and so we're left over with 240. So it's saying when when our t is 0, at 0 seconds, the height is at 240. So when we go back to our chart, that means it's somewhere like right here, and that sounds about right. Okay, so what does that mean? So all that really means is that that is the initial height at which they threw the ball. Okay, so probably the building, the 23-story building, is somewhere right here, and that's where they threw this ball. So what we can say is that what is the value of h of t? The value of h of 0 is 240 feet. What does it mean in terms of the problem? It is the initial height of the ball. In other words, the starting point. Okay, and in this case, like I said, bringing back what this represents the y-intercept as well. Okay, so you can also make a side note that when the input is 0, it will refer to the y-intercept. Okay, and usually in any word problem, it's going to represent the starting point of which the ball is thrown, or if it was a rocket, at which point it was started to launch, or if you think of anything, or like a football player, like that's probably where the one of the players just threw the ball at a certain height. It's the starting point. Okay, so that's an important thing to know. All right. Okay. Well, that is it. So go ahead and write your summary. And if you have any questions, you want to include those as well. So before we were working with area problems. This case, we are working with parabola problems that involve solving with zero product property and factoring. Again, you can pause, rewind, however you want to if you got lost. But that's it. All right. Bye.